we are going to have a party.
Oh.
You ready? You want to have a party, right?
Fraction Friday.
Yeah, we're going to have a pizza party. I'll bring the pizza. Here's the pizza. Yeah? It's the best pizza you ever seen. You can have as many slices as you want. I'm generous today. Oops, I messed up my pizza. You don't mind sharing pieces, do you? We're gonna have a pizza party. Yay! Here's our pizza party. Pizza. How many pieces of pizza do you want? You can have more than one.
2.
Okay, 2. Yeah, I would have 2. Jeff, you look hungry. How many pieces do you want?
I'll take 4 of them.
4? I'm going to give you 3, greedy. Come on.
You don't see how much I wanted.
You don't have to be greedy about it. Jeez. It's just imaginary you want 4. My gosh. So how much pizza have we eaten? Well, firstly, if we have a fraction up here, how many pieces are total in our pizza?
8.
8.
How much did she have?
She had 3. No, she had 2.
She had 2. So she had 2 pieces out of how many pieces?
8.
Would you say she had 2/8 of the pizza?
Yes.
She had 2/8. She had 2 out of the 8 pieces that were there. However, Jeff over here, Hungry Jeff, had how many?
3.
Good. He had the 3 pieces out of the 8 total pieces. You with me on this?
Yes.
How many did they have altogether between the 2 of them?
5 8.
They did. She had 2. He had 3. Together they had.
5 8.
We just added our very first fraction in this class. What this tells us, what, did you like the pizza party? Did you have fun? Was it good? Awesome. Yeah. We'll do this thing. I'll tell you what, we'll do it again since you had so much fun. We'll do it again another time, okay? We'll have more pizza parties. In this section, in section 4.4, we're going to be adding and subtracting some fractions. This tells us, though, it actually does tell us a whole lot about how to add and subtract some fractions just by looking at our pizza party example. When we look at this, we go, okay, we do have a fraction, 2 out of 8 pieces. There was 2 pieces shaded out of the 8 total pieces, plus 3 out of the 8 total pieces, and we got 5 out of the 8 total pieces. We can see that graphically, that the 2 plus the 3, that equaled 5. But we didn't make this more pieces, right? When she had 2 pieces and he had 3 pieces, we added them together, they had 5 pieces. It was still out of 8 slices, wasn't it? It didn't magically go from 2 pieces out of 8 and 3 pieces out of 8 to 5 pieces out of 16. Why don't we add those numbers? We add the top numbers. Why didn't we add the bottom numbers?
There's how many pieces in the pizza?
Yeah, that's how many pieces are there. We're talking about the same pizza, right? If we're talking about the same pizza in all 3 cases, we're not going to have 8 slices here, 8 slices here, and then magically we get 16 slices. I didn't cut that pizza anymore. We're just adding parts of the same pizza together. Raise your hand if you feel okay with that. For this reason, when you add and subtract fractions, we just learned 2 things from this example. Number 1, you must have a common denominator. The denominator in these fractions are 8. They have to be the same. If I had 2 different pizzas and one was cut in 6 slices and one was cut in 8 slices, and I say she has 2 and he has 3, but they still had 5 slices of pizza together, but they're different slices now. Does that make sense? We wouldn't be able to add that. We'd say, okay, we had 5 slices out of, wait a minute, there's only 6 in this pizza, there's only 8 in this pizza. That doesn't make sense. We can't add those together. We have to have the same number of slices in our pizza to add them together. So 2 things. Number 1, fractions can only be added or subtracted if they have a common denominator. Fractions can only be added or subtracted if they got a common denominator. Oh, because we had the same number on the bottom, we can add those fractions. Now I am going to go ahead and add one more step up here. Typically, the way we do our fractions, this is going to help you out when you get to your Math A and your Math C class, because when you get there, you're not just going to have numbers, you're going to have variables. What we're really doing is adding the 2 plus the 3 and keeping that denominator the same. That's what's giving us the 5/8. So we add our fractions if we have a common denominator, and second thing, the denominator will stay the same when you're adding or subtracting your fractions. We didn't cut the pizza into more slices magically. It stayed 8, 8, 8, 8 the whole way down. So number 1, fractions are added if they have a common denominator. Number 2, the denominator will stay the same. The denominator will not change. The denominator doesn't get added here. The denominator doesn't get subtracted when we subtract. It doesn't change. When you're doing addition subtraction. Shall we try a couple examples to really kind of illustrate this idea? You guys ready for that?
Sure.
All right, so let's do some examples over here, and then I'll come back and work on this side. Let's say we have 6/13 plus 2/13. The first thing you need to check for is if you can add these fractions the way they are. The way you determine that is if you have a common denominator or not. Common means the same, denominator means the bottom part of a fraction. Do I have a common denominator?
Yes.
So can I add them together?
Yes.
Now, essentially, all we do right there is identify that these numbers are the same. Am I going to get 13 or 26 here?
13.
Good, that denominator is not going to change when you're adding or subtracting. I get 13, I don't add them. That would be like you're cutting the pizza up into more slices. We're not doing that. On the numerator, we get whatever's here, whatever that sign is, whatever's there. We're taking the numerators and doing that operation between them. So if it's addition, you're doing 6 plus 2. If it's subtraction, you'd be doing 6 minus 2. So we're looking at the numerator, that sign, that numerator, we're putting that on the top of our fraction, and essentially what we're doing here is we're changing a fraction problem into a simple addition problem. This is going to be especially useful when we get to positive and negative numbers. All those integers, this step's going to be really, really nice for us right now. Because right now you're probably thinking, well, I can do that in my head, that's 8. Yeah, no kidding, no problem. But when you put some negatives up there and you start doing more and more fractions together, it's very helpful to write that as one fraction first. Are you with me on this? Especially with those negatives. Trust me on that one. You don't want to mess up the signs. Here we get 8/13, and then you're going to do one thing. You're going to try to simplify this. Can you simplify 8/13?
No.
But you should be checking for it. You see, this is different. Addition and subtraction is different than multiplication and division. With multiplication and division, you could simplify as you went. Remember that, crossing out those numbers? Unfortunately, with addition, you can't do that. You can't simplify here. You certainly can't simplify across them. That only works for multiplication. The only time we can simplify is at the very end, and that's when we would check. Okay, oh, you knew I had to throw some variables on that thing. We got 5 over 8x, we've got 1 over 8x. Catch. Are these fractions addable?
Yes.
Yeah, what tells you that? Cool. So when I write my equal sign over here, what's going to be on the bottom of my fraction?
8x.
Okay, it's not going to change. On the top, I'm going to spend some time and write 5 plus 1 just to make sure I understand that it's a numerator, the operation, the other numerator. We're going to get how much?
6 over 8x. What if it's 8x squared?
No, it wouldn't. You do not change the denominator when adding subtracting. So if it's 8x and 8x, you keep doing 8x. Good question.
What about the 2 over 8 or 3 over 8? Like, can you simplify the 2 8's?
We're going to get to that right now. So, first question, 1 second. Could you have simplified this fraction?
No.
This one. Does 5 go into 8 at all?
2 goes into.
Could you have simplified this fraction?
No.
Can we simplify any of these?
No.
Can you simplify that?
Yes.
Yeah, weird, huh? With addition, it doesn't happen till the very end. But you cannot simplify until the very end. If you went back up here, we know for sure this is 5/8, right? Let me show you what would happen if you tried to do what I'm telling you you can't do. If you tried to simply look at the board, everybody. If you look at this and say, okay, well 2 goes into 2 one time, and 2 goes into 8 4 times. Is this the same thing as 4 over 4? Is that equal to 1?
No.
No.
Do you see how some people would make that mistake if you're really not paying attention? If you try to do the same thing with addition that you did with multiplication, which is simplify the 2 and the 8, you get 1, you get 4. 1 plus 3 is 4. 4 is 4. This fraction says 1. This fraction says this. It says she had 2 pieces, he had 3 pieces out of 8, and they ate the whole pizza. Does that work?
No.
If I have a pizza with 8 slices and she has 2 and he has 3, it better not be gone. I'm going to be pissed. Right? Worst pizza ever. That would suck. Yeah, that would be the mistake in adding these fractions. You can't do that. So you need to get this down. You cannot simplify addition, subtraction until the very last step. Otherwise, you're doing like this, having 5 slices of pizza and thinking you have the whole thing. Okay? You might feel like you have the whole thing, but you don't. So in our case here, we can't simplify until the very end, but now you could. At the very end, when you've already added them, you get 6 over 8. We can simplify 6 over 8. Well, it goes into both 6 and 8.
2.
2 goes into 6 how many
3
times?
times 3.
And
4.
don't forget about the x. That's right. 3 over 4x. That's your fraction. Remember, we're dividing the number on the top and the bottom by a common factor. Nobody had a question?
Oh, no, yeah.
I did? I love how that happens. You guys ready?
Yeah.
Can you still add them?
Yes.
Yeah, there's more than 2 of them, but who cares? It's the same idea. First thing you look for is a common denominator. Do we have a common denominator?
Yeah.
So what we're going to do is do the same idea that we just did up here. When we're adding fractions together, we know that our new denominator is going to be what in this case?
Yeah.
Good, because it doesn't change. Can you tell me what's going to be on the top of my fraction if I'm doing this appropriately?
33.
33.
So before I do that, I want to write this appropriately and do what this actually means to do. Trust me, this is going to help you when you get to positive and negative, I promise. Here we'll have 20 plus 6 plus 7. Now add it. Just do that extra step. I know it takes like 2 extra seconds. Take time on these things. I'd rather have the right answer than the fast answer. I'd rather have it right. 33.
Do you simplify it, or do you like turn it into a mixed number? A mixed number?
Well, you're going to get 33 over 11, right?
Yeah, for
Which is
3.
3.
That's 3. Yeah, simplify it. Now, you can't simplify until this step, but definitely do simplify it.
So if you simplify it 2, it's going to be 3 over 1, which equals 3.
Exactly. Yeah, we're going to get 3 out of that. 3 over 1, 11 goes into both 33 and 11. 3 times in the numerator, 1 time on the denominator. 3 over 1 is 3.
So like, what's that, another fraction that gets a mixed number instead of 3?
For instance, if you had like 34 over 11,
3 over 11.
you could leave it as 34 over 11 if you wanted, or you could write it as 3 and 1/11. Okay, I don't care. What I'll tell you is that the problems I give you are going to kind of dictate what you need to do. If I give you mixed numbers, I want my answer in mixed numbers. If I give you non-mixed numbers, I don't really care what you do after that. I'd like to see that, and then well, if it was 34 over 11, just I want to make sure you have 34 over 11, and then if you want to go the extra step and do the mixed number, that's fine. I'm not going to mark you off for doing extra work, just want to make sure you know you don't need to do it in this case. Okay, does it work the same for subtraction? Let's see. Firstly, can we subtract these two numbers, folks?
Yes.
Yeah, we got a common denominator. We should be able to for sure. So we got that common denominator of 12. What is our new denominator going to be?
12.
Now, here's the deal, right? The reason why we don't change denominators, if you did that, if you did 12 minus 12, how much would you get? Can you divide by 0? That would be a problem. You would get undefined for every subtraction problem you ever get. Right? That would be a big mistake. So we have 12 and 12. Denominator is 12. On the numerator, what are we going to get?
5.
Before you do 5, you're going to write what?
11
That's right. Can you simplify 5/12?
Nope.
You are done. Let's try that one for me, okay? Well, it's kind of nice. You got a common denominator already. So when we do this, we're going to have, I know something over 15. What we're going to put over 15 is a 7 minus 2. Hopefully you got 5 over 15. Did you get 5 over 15?
Yes.
Notice how you couldn't simplify here, you couldn't simplify here, you definitely can't simplify here, but yet at the very end you can. 5 over 15, you need to check simplification at your last step. How much?
1/3.
Right. It's not 3. No, when we're doing this, remember what we're doing is dividing both the numerator and denominator by the same number. So we look for a common factor. We know that 5 divides both those numbers, and you divide each number by 5. You leave them in the spot where they are. 5 divided by 5 is 1.
Yeah.
15 divided by 5 is 3. That gives us 1/3. Let's put some negatives on there and see what we do. Well, we got negative 8/17 plus 4/17. Now, there's something I need to show you that's kind of neat about fractions. Fractions, it doesn't matter where the negative actually is. So let me show you something that's going to help you deal with these problems a little bit better and kind of show you why we do this whole step right here. Here's why. If we have negative 8/17 plus 4/17, there's something you need to know about this. And here's a little note for you. If I have negative AB, negative AB with that negative in front of the fraction is exactly the same thing as negative A over B. It doesn't matter whether I have the fraction out front or on the top or even on the bottom, on the numerator or the denominator. What I'm going to choose to do, every time you see a negative out in front of your first fraction, move it to the top of your fraction. Are you with me? Every time you see a negative out in front of your fraction, move it to the top. The reason why you're going to do that is because when you have a common denominator, which you do here, you're going to be doing this step, right? You're going to write that as one fraction. It will automatically move the negative to where it's supposed to be. Here's the problem, ladies and gentlemen. Here's what people make a big mistake on this stuff. They'll forget about the negative. They'll go, oh, that's 12. Do you see how easily that would happen? Like if you're not really paying attention to the negative, you go, oh, that's 12. I get negative 12/17. That happens a lot, and I can't afford to have that happen. So with us, when we see something like negative 8/17, we're going to write this as negative 8 over 17.
Basically, you had the addition sign, but you're going to subtract it.
We're going to see. We're going to see in a minute. Right now, the only thing I want you to realize is that anytime we have a negative out in front of a fraction like this, we can automatically move that to the top of our fraction. Raise your hand if you're with me on that one. Feel okay about that? Good. So what I'm going to do is I'm going to rewrite this, or you can erase that negative and just put it on the top of our fraction. I know that I'm going to have negative 8 over 17 plus 4 over 17. Now I already have a common denominator. You tell me what my new denominator is going to be, please.
17.
And since we moved that negative to the top of our fraction, look what our process says to do. It says you're going to take this number, which is now not positive 8, but negative 8, plus 4. And that changes a fraction problem with a negative into just a simple addition rule problem with negative 8 plus 4. We can do negative 8 plus 4. We know addition rule says different signs, subtract, sign of the bigger number. How much do you get out of that? That's right, negative 4. Negative 4 over 7, and you know what? You can even go in reverse of this thing. If you don't like the negative 4/7, you could write negative 4/7 like that. They're the same. They're identical.
How do you get the 7?
Oh, like 17. I got the 7 by magic. Done. Do you like it? Harry Potter math pen. Magic. Yeah, I forgot the 1. That's the truth of it. Try one on your own. Negative 11/8 plus 6/8. Go for it. So first thing I'd like to see from you, of course we're going to move that negative to the top or numerator of our fraction before we do anything else. That makes that sign applicable to the next step. Next we'll check for a common denominator. Of course we got one, so we know we're going to write one fraction out of it. Take our numerator plus the other numerator and do the math on it. Negative 11 plus 6, how much does that give you?
35.
Good to go. Did you get that? Good, all right. Wow, what if I put some variables up there? Let's see what that does. Firstly, can you subtract these two fractions? Okay. Okay, what tells you you can subtract them? Awesome. So we know we're going to write one fraction out of this. What's on the bottom of our fraction?
5.
What's on the top?
2 minus.
2 minus 7.
That's a y. That's kind of why this step is nice, right? We know this process. We know we can write 2 minus 7y. It works like that. Now, can you combine 2 minus 7y?
No.
Can you get negative 5y out of that?
No.
What do you think?
No.
If I give you just this
I
problem.
think it's been worked out.
Hey, oh yeah, are those like terms?
No.
No.
Can you combine terms that are not like terms?
No.
You're done. You can't combine those. That's like saying you got $2 and you owe 7 yellow bananas. Can you combine those? No, it doesn't make sense.
Are there other
You can't
colors?
owe 5 yellow bananas. There's green bananas. So you're done there. They're not like terms, you cannot combine them.
But if it's multiplication, you can?
If you had a multiply there, if we were actually multiplying, sure, you get 14y. So addition, subtraction is different than multiplication, division.
I got 5 y over 5 and I'm going to do that y. Not that like 5 y over 5.
How about that one? Are we going to be able to subtract those?
Yes.
Yeah.
Sure, we got a common denominator. Let's go ahead, let's make one fraction out of it, and then we'll see that we're able to use our addition rules to solve the rest of our problem. So here we do, okay, common denominator gives us 11. How we write the top of a fraction, we'll have our 4 minus 6 minus 3. If you really look at that, that's something we've had before in this class, from back in chapter 2. Ignore the denominator, you get 4 minus 6 minus 3. You could do a couple things here. You could change those to plus negatives. Do you remember doing that? It's bringing us some old stuff. Remember changing that to plus negatives? You could do that. If you're good at the subtraction, leave it like this. Just do your 4, how much is 4 minus 6? So you can do negative 2, and then minus 3. You're talking about negative 5 here. If you want to see the work on it,
Is that what it is?
you can show that, right? You show that. You can do plus negatives. You can do them 2 at a time. 4 plus negative 6 is negative 2. Negative 2 plus negative 3,
So then,
negative 5 11s.
I'm thinking it's just subtraction sign that they're not negative numbers.
You're changing them into negative numbers if you change it from a minus to a plus negative. That was the process back in chapter 2. If you want to think of it as a minus, just do 4 minus 6, but you better be getting negative 2 out of that.
We'll combine like terms.
Okay, last thing I need to show you in our section here, before we talk about something called LCD, which will be very interesting. Can you evaluate? X minus y, when x equals negative 8/10 and y equals negative 3/10. Hey, what's the first thing you do when you evaluate? Okay, we got to substitute, and we got to do it correctly. So let's go slowly on this thing. Don't rush through it, all right? You rush through things, you get wrong signs. That's what happens. Let's make sure we get this part right. If I'm going to do x minus y, can you tell me the first thing that I need to write on my board?
Negative 8 over 10.
Perfect, because x is negative 8 over 10, I'm going to write negative 8 over 10. You okay with that one? What's the next thing I need to write?
Minus.
Okay, a minus sign. Here's the big deal about this problem. You got to realize that the minus sign is going to be there regardless of what y is. Are you following me on that?
Yes.
No matter what, that's going to be the way it is. Next, we look at the value of y. How much is y?
Negative 3.
So this doesn't count for that negative. This counts for the minus. Now for the y, I need to write, okay, negative 3/10. And just to be safe, I'm going to put that in parentheses so I don't get those two things confused.
Are you going to change it?
We are. That's a minus. That's a negative. Let's think back to our rules for addition and subtraction. What do you have when you have a minus and negative? You could change that to a plus, right? Sure. In fact, you have a common denominator. I want you to see this part. You have options here. You have choices. You can change this to a plus right now, and you'll be just fine. Or, look at the board. Or, if you do the next step, you could do the common denominator of 10, and on the top you'd get negative 8 minus negative 3. Do you guys see that? Minus negative. Doesn't that change to a plus anyway?
Yeah.
You do it either way. I don't care where you do it, as long as you realize that a minus and negative does give you that plus. I'll leave it this way since I already wrote it. We'll do negative 8 plus 3 over 10. If you changed this to a plus, if you change this to a plus first, you'd still get the same exact thing. Verify that for me on your paper if you did that. Okay? And lastly, what's negative 8 plus 3?
Negative 5.
5/10 or negative 5/10?
Negative 5/10. You simplify it?
What do you think?
No.
Yeah.
We have negative 5/10, so we better know how to simplify that. What's that equal to? Yeah, we divide both the top and the bottom by, I can't do that, by 5. We get 5 divided by, negative 5 divided by 5 is negative 1. 10 divided by 5 is 2. That's as simple as we can make it. You get negative 1/2. Raise your hand if you feel okay with these fraction examples. Now, the question I have for you is, do we always get a common denominator right off the bat? Are all of our fractions always going to be
No.
11, 11, 11?
No.
No. Or 10 and 10? No. Sometimes we get fractions that don't have a common denominator. In that case, for instance, if I change this to like 7, would you be able to subtract those fractions?
No.
The first two?
Yeah.
The last one?
No.
Not like it is. We've got to find a way to find a common denominator. If we're not given one, we've got to find one. Because the only way we can add and subtract fractions is if we have one. So we're going to talk about right now how you find the least common denominator. We don't want the biggest one, we want the least, the smallest one. So we're trying to find the smallest shared denominator, lowest common denominator.
Yeah.
So least common denominator. Denominator is the bottom of a fraction. Common means shared. Least means smallest. And we abbreviate this usually with LCD. We'll be using that a lot in this class, LCD. What this is, least means smallest, the smallest number that has both denominators as a factor. What that means is that both denominators divide this number, and it's the smallest one that happens. The smallest number that has, I'm going to say instead of both, we could be dealing with more than one fraction, so that has all of the denominators as a factor. Let's look at 7/8 and 11/16. Now, I'm not looking to add or subtract those. I'm just looking at the fractions, okay? Firstly, would you be able to add or subtract those the way they are right now?
No.
Why not?
Because they have the denominator not the same.
Perfect. So we look at that and go, okay, we got 8, we got 16, that's not the same. I can't add them, I can't subtract them. What we're looking for is how to find the common denominator. The first part of that is identifying what it should be. Now here's how we do it. I'm going to give you some steps to do this. The first steps you're going to do, you're going to identify the largest denominator. I want to tell you there's other methods to do this. This one's the fastest. It works for numbers that are relatively small. Start with the largest denominator. Which one is the largest denominator here?
16.
We're going to start with 16. We're going to find some multiples of that denominator. Are you familiar with what a multiple is?
Yeah.
Are you sure, everybody?
Yeah.
Nod your head if you're familiar with the multiple is. Shake it if you're kind of like, I don't remember. It's fine if you don't remember. We'll go over it right now if you don't. Okay, here's a multiple. I'll start and you can fill in the rest of it. We're going to do the multiples of 4. The multiples of 4 are, the first one is 4. The next one is 8. What's the next multiple? 12. And then?
16.
And then?
420.
And then?
24.
And then?
28.
There's only a couple people doing this. Let's do the multiples of 7 now. The first multiple of 7 is 7. What's the next one?
14.
What's the, hang on, wait, let people think. What's the next one?
21.
What's the next one?
28.
And then?
35.
Those are multiples. It's the numbers you get when you multiply by sequential integers or whole numbers. So you take, if we're talking about 7, 7 times 1 is 7, 7 times 2 is 14, then 21, then 24, then 35, and so on. Those are multiples of a number. What we're doing, we're looking for the largest denominator, which is 16. We're going to start finding multiples of that number. The first multiple that all the other denominators divide, that is your LCD. The first multiple that all the other denominators divide. Is the LCD. Do you have that written down? You ready to give this a try? Let's go back to our fractions here. We got 7/8, we got 11/16. What's the largest denominator?
16.
16 is the largest one. We're going to start with a 16. You start finding multiples of 16. The first multiple of 16 is 16. That's itself. Then you check all the other fractions and you see if it divides that number. Does 8 divide 16?
Yes.
Yeah, well, we're done. We look for those multiples. If it divides it already, that itself is your LCD. So we'd say, okay, largest denominator is 16. Check to see if 8 goes into 16. It does. Right there, you know that 16 is your LCD. So automatically we're done. We go, okay, we didn't even have to find another multiple. We're going to write LCD is 16. That's the first number that both of those denominators divide. Is there anything smaller than 16 that both 8 and 16 divide?
No.
Is there anything bigger?
Oh, yeah.
Sure, there's lots of stuff bigger. There's 32. There's 64. There's lots of stuff. There's 40, I think 48. There's 48 that works. Do we want the biggest denominator or the smallest?
Smallest.
So don't give me stuff like 64. Don't give me 18 times 6. Oh my gosh, sorry, 16 times 8. That'd be way too big. We don't want that. That's huge, right? We want the smallest one. So here's how to find the smallest one. You start with the largest denominator. You find the first multiple they both divide. That's the smallest possible thing. You're not just in the business of multiplying denominators here. That you might have been taught that a long time ago, that to find a common denominator, you just multiply this by 16 over 16, you multiply this by 8 over 8. That will work, but it will give you huge numbers. Huge numbers. We don't want to deal with that. We want the smallest ones. It makes it easy.
Number 2 or no?
Right now, I'm not concerned about the numerators. All I care about, we're doing step by step. I'm just worried about the denominators right now. We're just worried about that. I want you to be able to find an LCD, and then I'll build off of that. You ready to try a few more? You sure? Do you have questions on that one? Okay. We'll do one more and we'll stop there for today. That's where you're supposed to go, "Aww,
Oh.
I don't want to stop. This is fun." Right? Right? Yes, sir. Yes, sir. You bought your pumpkins yet? I think I was wrong about that, by the way. There's plenty of pumpkins. I see them all over. Okay, we're going to find our LCD. So the first thing we're going to do, locate your largest denominator. Notice how the numerator really doesn't play a part in this right now. We're just looking at the bottom of our fractions. What's the largest one?
120.
So we're going to start finding multiples of 20. Here's the first one. The first multiple of 20 is 20. Does 12 go into 20?
No.
Does 12 go into 20? What's the next multiple of 20? 40.
Is 60 the lowest common denominator?
I don't know. We're going to find out right now. Hold up. Just hold on. Wait. Does 12 go into 40?
No.
So you gotta keep going. What's the next multiple?
60.
Does 12 go into 60?
Yes.
Yeah. Okay, yeah, it is. That's the LCD. You find the first one, 20 didn't work, 12 didn't go into that. 40 didn't work, 12 didn't go into that. 60, 12 goes into that. That right there, that's your LCD. So we take the largest one, we find the multiples, the first one that they both divide, that's your LCD. The reason why we don't start with the smallest denominator, you'd have to do more multiples. You have to do more work. You have to do 12, 24, 36, 48, and 60 before you found it. This is less work. Start with the biggest one. How many people understood what we talked about today? Good. Okay, so we are finding LCD. And again, the way that we're practicing doing this is we're trying to find the lowest or the smallest number that have both of our denominators as a factor. The quickest, easiest way to do this, again, is to take the largest of your denominators. We're not really even worried about the numerators right now. We will be in the next section, but for right now, we're just looking at these numbers, the bottom numbers. Take the largest one. That means you'll have to do less work, less multiples to find the lowest common one. So we start with not 6, but 8. We're going to find 8, and we check every single time we have a multiple whether the other denominators divide it. So we're going to start with a multiple of 8. Does 6 go into 8?
No.
So we have to go to the next one. What's the next multiple of 8?
16.
Okay. Does 6 go into 16?
No.
Okay, we got to do another one. What's the next one?
24.
Does 6 go into 24?
Yes.
Yeah, you see, by taking multiples, you're automatically finding numbers that 8 divides. Automatically. 8's going to go into all of these numbers. The first one that 6 also divides, that has to be your lowest common denominator, since 8 already goes into it, and you're making sure that 6 does as well. 24, in this case, is our LCD. Did you find 24? Yes. Good. Okay, next one, 4 and 7. We're going to start with what number, 4 or 7?
7.
For sure. 4 clearly doesn't go into 7, so we're going to continue. We'll do our 14. Does 4 go into 14?
No.
Okay. Then we got 21. Does 4 go into 21?
No.
Next up, we got 28.
Yes.
Yeah, so 24 here, 28 here. Now, I'd like to show you something on why sometimes this process works. I'll show it to you. And other times it doesn't. Can you look at the board for me real quick? Notice how when we got 28 here, what is 28 compared to 4 and 7? How would you get from 4 and 7 to 28?
4 times 7.
Yeah, in this case, this is, if you wanted to find LCD, you would multiply those two numbers. You see that? But up here, it didn't work like that. If you multiply 6 and 8, you get 48. That's way bigger than 24. That's twice as big. Why here isn't the multiplication of those denominators, but here it is. Say that one more time.
Because the top one is both even numbers.
Yeah, they are even. Did you guys notice that they're even? That means they have a shared factor. If you have a shared factor, that's already part of the puzzle piece. That's already part of your LCD. You don't have to multiply that in there again. You have counted that factor twice. So whenever you have shared factors like 6 and 8, 2 divides both those numbers. That means you're going to get smaller than just the multiplication of those denominators. However, if you look at 4 and 7, nothing divides both 4 and 7 besides 1. That means that you have no shared common factors. That means that our denominators, our LCD is going to be the multiplication of those two denominators. That's one way you can check that. It's kind of interesting. Okay, our last one up here, we have 8 and 12. Do we have a shared factor?
Yes.
Yes.
Yeah? What's the number that goes into both 8 and 12?
24.
24 goes into both 8 and 12?
4.
Okay, 4 goes into both 8 and 12. Here's what I'll bet you. I'll bet you $1 million that this happens, okay? I'll bet you that if you multiply these two numbers and you divide by their shared common factor of 4, you're going to get 24. That's what I'll bet, the LCD. And that's what happens when you have the shared factor. You don't necessarily have to multiply both of these.
Are we getting the common factor or no?
We're going to get the LCD right now. Yeah.
The LCD is not a common factor, is it?
LCD is not a common factor. There's two things we're talking about here. The LCD is the lowest common denominator. It is the multiple which both numbers share that's the smallest. That's LCD. A common factor would be a number that divides both those denominators. Now what I'm telling you is that if you have a common factor, your LCD will not just be the multiplication of those two numbers. Here it was. There's no common factor. Here we had a common factor. It's not just 6 times 8. Here we definitely have a common factor. It's 8. It's not going to be 8 times 12. It'll be smaller than that number. So when you have a common factor, it lowers the LCD. You don't just have to multiply those two numbers. That's what I'm trying to get across to you. So in our case, we'll still do it the same way. We'll still do 12. Does 8 go into 12? We check the next one, which is 24. Does 8 go into 24?
Yeah.
Yeah, that's it. As soon as we find that number, that's our LCD. Raise your hand if you're okay finding this LCD stuff. Good. Now we got to take this one step further. You see, we're going to use the idea of an LCD to make a fraction look a little bit different so that we can add it and subtract it. Because ultimately, we know we can't add or subtract fractions unless we have that common denominator. So how do we make up a common denominator? Well, that process is called finding an equivalent. Say equivalent for me. Yeah, equivalent expression or an equivalent fraction. Equivalent means same value, but it looks different. Here's what I mean by equivalent fractions. If I give you this fraction, would you say those are the same value or different values? What do you think?
Same.
Why? Very good. So if I simplify this, which means divide by a number on both the top and the bottom, thereby equaling 1, right? If I do that, it's going to equal 3/5. You all agree? So these are the same exact fraction. What I'm asking you to do now is instead of me just telling you those are equal, what I'm going to have you do is create your own equivalent fractions. And here's how we're going to do it. I'm going to give you some expression that says 3/5 equals something over 10, where I don't know what the something is initially. I'm asking you to find it. So you have to think in your head, what fraction is going to be the same as 3/5, only instead of having a 5 down here in the denominator, I now have a 10. And here's how you figure this out. What you got to ask yourself is, what number did I need to multiply by in order to get from 5 to 10? Because what we know is if we multiply the denominator by a number and the numerator by the same number, you'll have an equivalent fraction. That's the idea. So let's do that. What number do you have to multiply 5 by in order to get 10?
2.
Okay, multiply by 2. What that means is this. If I multiply the numerator by 2 as well, I'm going to get an equivalent expression. What is the 3 times 2?
6.
Yeah, and that gives us that fraction we were just looking at. That's how you change one fraction into an equivalent fraction. Shall we practice some more of them?
Yeah.
Okay. Again, I'm going to give you I'm going to give you everything but one missing piece. Your job is to find this missing piece every time, okay? That's what's going to happen here. You're going to find out in the next section that this piece right here comes from your LCD, and this missing piece is what we're always trying to find. We have 7/8 equals something over 56, and again, our job is going to be to try to find this number. Now, I'll walk you through it to show you how to kind of think about this. You start with the numbers you're already given. In this case, we're given a pair of numbers right here. So you ask, how in the world do I get from 8 to 56 by multiplication? What do you need to multiply by to get from 8 to 56? Okay. That's the way fractions work. If you knew you multiplied times 7 to get here, we're going to do exactly the same operation on the numerator. You see, if we multiply by 7 on both the top and the bottom, we get automatically an equivalent fraction. So we multiply this by 7. How much are you going to get when you do 7 times 7?
49.
You know what? You can check your work. Simplify this fraction. It must give you that one back. That's how you check to see that you have an equivalent expression there. Does the same thing work? If I have a variable, oh my. Let's see. Let's see if we can still do that. Would you know how to get from the 7 to the 42?
Yes.
Sure. Times what?
8. 26.
Times 6. As soon as you find that number, you're halfway done. Because all you got to do is take that times 6, do that to the numerator, and you will automatically have an equivalent expression. So let's multiply by 6. Can you tell me what is 3x times 6, please? Perfect. We're going to write that right up top. And you're done. That's your equivalent fraction. Like it?
Yeah.
We're gradually moving up to how to add and subtract fractions without common denominators that are already given to you. I'd like you to try a few on your own. There we go. Let's give those a try. They go kind of quick once you get the hang of this. So we look at our fractions, we find out how you get from one denominator to the next by multiplication. We do that operation to the numerator, we have a new fraction. So in our very first example, I see 2/5 into something over 15. I'm looking right here, I'm seeing that 5 times 3 is going to give me that 15. So I know that this is times 3. I do the same thing to the numerator. And I'm going to get 6 over 15. Did you get 6 over 15?
Yes.
Good deal. Okay, next up, 1/4 into 20, well, something over 20. What is that?
Times 5.
Definitely 5. That's going to give me how much?
520.
Hey, check your work real quick, can't you? Just look at 5/20ths. Make sure that's the same thing as 1/4. You know for sure those are equivalent fractions. How about 9x over 11 equals something over 44? What are we multiplying there?
4.
So we multiply this times 4. Same thing on the numerator.
36.
Good, 36 what?
Yes.
Don't forget the x. Don't just give me 36 over 44, we'd be losing that x. Wait a minute, how about 4 into something over 6?
Make it a fraction.
How?
Over 1.
Okay, so we can do that. And if we consider this 4 over 1, we're definitely not finding out how 4 went into 6. That wouldn't even make sense, right? They're not going to multiply by 1.5. That'd be crazy. So we make this into a fraction. We find out how many times we have to multiply 1 to get 6. Well, of course, that's 6. And if we do that to the numerator,
24.
does it make sense that 24 over 6 equals 4?
Yeah.
Yeah.
Sure, yeah, we can do that. And lastly, oh, did you get this one? 4x
Yeah.
into 36x.
Times 9.
What do you multiply there?
Times 9.
Yeah, no x's, because the x is already there, but sure, 9. Hey, if the x wasn't there, could you have seen that you multiplied by x? For instance, if I covered that x up with my finger, you'd have to multiply by x there too as well. Would you see that?
Yeah.
Okay, good. So times 9 there. Times 9, how much are we going to get?
81.
Would you raise your hand if you feel comfortable doing this equivalent expressions? Cool.